Okay, I'm going to try this video again. It says below 1st of June. That's when I first tried this. And we had some audio issues. One of the problems is there's bottlenecking of data due to things being busy on processing because there's no dedicated graphics card. So and it's a 8GB system. I would prefer it to be 16. That's going to change hopefully soon. We get 16GB on this. There's no, like I said, there's no dedicated graphics card though. So ultimately I'd like to build something so we can deliver this much more professionally and have things run a little bit smoother. Let's get into the SR71 though, and this image is of a flight where they literally chased the sun. They saw a number of sunsets because they was able to catch up. The craft, the SR71 is a military reconnaissance aircraft and way ahead of its time, flown in the 1960s, still flown in the 1990s with some missions and projects. We get into what I mean by projects in a bit. Really high altitude, high speed, a reconnaissance craft. The speed was 3 times that of the speed of sound, otherwise known as Mach 3. It was pushed, tested a little bit between a conversation between two pilots. Let's see what this can do, so to speak. And there was clocking up, going smooth as butter was the term used, I think, if I remember rightly. And you know, transitioning Mach 2, gliding in, the numbers clocking up Mach 3. You know, still going up as well. It went just above Mach 3 actually on the official data. That's just the official, and you got to put a number on something and say this is what the speed we do. But they pulled it back. It was gliding up, getting close to. They thought it might reach Mach 4, but they brought it back because it was getting a bit scary. Amazing, right? And we get into one of the things that enable it to be so fast. But there are a number of things that you might not expect to hear about this craft in terms of how you think of a military craft. Even if it was advanced for its time, you might not think certain things. Kind of like what I'm going to go into now. NASA's research on the Mach 3 speeds. Part of that research for the speed was applied to this craft for testing speed, like the velocity and air pressure. There's a number of versions of this craft, and it was, you know, an advanced way of measuring speed and air pressure was installed on one of these crafts. Whether it was this particular one, I'm not sure, but it's a 104 Starfighter. And it's called Starfighter because of its shape. You'll see why if you looked it up and looked at some other shapes. And almost looks like some kind of sci-fi starfighter thing, the shape. And certainly going with shapes, this is way ahead of its time, the SR71. There was a number of precursors to eventually creating the SR71, and of course, like the Starfighter, there was a number of test and testbed type technologies, if you will, that eventually were harnessed and perfected and applied to the SR71. It took 24 hours to prepare the SR71 for any flight, a mission. Getting things ready, complicated craft, and not without its problems. Very costly, but very way ahead of its time. So there's this one, which was a precursor. It's the YF12. I think that's the model name. Not quite the SR71, but close. So we're getting into some of this now. Getting to the research that was done for the speed. One of the first major experiments to be flown in NASA, in the NASA SR71 program, was laser air data collection system. So like I've said earlier, to measure air pressure, speed, velocity and so on, it was a technology, the laser technology was apparently tried on these craft as well before they put it to the SR71, which is here. So one of the major experiments on this program, the NASA's SR71 program, laser air data collection, it used laser light instead of air pressure, actually. So, the air pressure was used to gather data on sensors, and you use that data, convert that data to how fast are you going, angle of attack, and so on. So I've got some information in front of me now, and I'll read this to you. It used laser light instead of air pressure to produce airspeed and altitude reference data, such as angle of attack and side slip, normally obtained with small tubes and vanes extending into the airstream, or from tubes with flush openings on an aircraft's outer skin. The flights provided information on presence of atmospheric particles at altitudes of 80,000 feet. This also went to highs of 85,000. Much of what's been said about it is like so high it's where space meets the atmosphere and the atmosphere meets space. And I do want to do perhaps a separate video, separate subject on that, because it's kind of, some people might say, well, that's debatable. Well, we'll get into that with the, how thin the atmosphere is, mitigate, it's certainly where space begins on the standard way of looking at it. So 80,000 feet and above, where they thought at the time future hypersonic aircraft will be operating, and I will be getting into a little bit about the SR72, which is a much more modern thing. It probably is not going to be called the SR72 officially anyway, and it might not be even a manned piloted craft per se. There might be somebody flying it, but they won't be in the cockpit. Yeah, we'll get into that perhaps as well. So there's a lot of information about this. It's way beyond the scope of the YouTube channel and the blog, but I'll read on to you a bit more. So the hypersonic aircraft, they thought that height would be where the future hypersonic craft would be operating. The system used 6 sheets of laser light projected from the bottom of the A model. There was a number of versions and models of the SR71 for these test beds and so on. So used on the A model as microscopic size atmospheric particles pass between the two beams, direction and speed was measured and processed into standard speed and altitude references. An earlier laser air collection system was successfully tested at Dryden on an F-104, which was that other craft I showed you. Tested on a F-104. Again, if it was that version, that variant, because there are a number of designs, or a different one, I am not sure. I haven't got enough information on it yet for that. But that was an F-104. Get back to the amazing craft here. And so the F-104 was a test bed for this before they installed it on the SR71. The first series of flights using the SR71 as a science camera platform for NASA Jet Propulsion Laboratory was flown in 1993. So, this craft is used quite a lot for many different things, and you tend to think of a military craft as this is a craft to be used at war, or observing potential enemy bases, reconnaissance, flying over, recording data, taking photos, and so on. However, NASA's Jet Propulsion Laboratory wanted to use this, and it was flown in 1993 from the nose bay of the aircraft. An upward-looking ultraviolet video camera was used to study a variety of celestial objects in wavelengths that are blocked to ground-based astronomers. This is very interesting how they word this, and another official who claimed to have worked on the SR71 and a contract for the CIA claimed that some missions, and only very, very few people would know about the mission. They know a standard mission of somebody flying off, but there would be a mission that had a secondary mission embedded into it that only a few people knew. And once they were up there, they were flying to observe objects coming to and from Earth. That was his words. So think of that what you will. And now I know there's a lot to be said about that. Some people are UFO enthusiasts, and they want to look at subject matter like that. But you got to be careful. The rabbit hole is a dangerously confusing place. Let's not jump to too many conclusions, but it's interesting that has been said. So they're studying these objects in wavelengths that are blocked to astronomers on the ground. SR71 also used in a project for researchers at the University of California, Los Angeles, otherwise known as UCLA, who were investigating the use of charged chlorine atoms to protect and rebuild the ozone layer. In addition to observing celestial objects in various wavelengths, future missions could include downward-looking instruments to study many things. So there would be downward instruments, radar, cameras, things looking in other spectrums of light that we don't normally process unaided. So this was looking at rocket engine plumes, volcano plumes, Earth's atmosphere, and many other things, as part of a scientific effort to reduce and protect the ozone layer. The SR71 operating as a test bed has also been used to assist in development of commercial satellite-based instant wireless personal communications network. Again, you don't think of it as the average layman. I don't think of it in this way until I look at this data. And military craft, I was flying out to observe potential enemy bases, perhaps reconnaissance, flying over bases, very stealth-like, too high to be targeted, too fast to be targeted, and all these things. That's what you think of. But there's many other applications of this technology at the time as well. So, operating as testbed for these things, commercial satellite-based instant wireless personal communications network was also called Iridium system. The NASA's commercialization assistance program, the Iridium system was being developed by Motorola's satellite communications division. Remember those old brick mobile phones in the 90s, back in 93, late 90s? Motorola phones? Yeah, that's who we're talking about there. I think Motorola still exists. They're still doing mobile phones, but now they'll be the more slick, more modern designs, of course. So during the development test, the SR71 acted as a surrogate satellite for transmitters and receivers on the ground. Again, you don't think of military craft as like this as satellite, but a lot of them are, because you got your radar systems, other systems reporting to and from the ground. That's what satellites do, right? But it had commercial application here as well. SR71 also been used in a program to study ways of reducing sonic boom overpressures. So basically, they're trying to reduce the risk of structural damage via sonic booms from craft going by when they break the sound barrier. You don't want your windows to vibrate and break, so they was looking at this, and reducing these sonic booms was important, and overpressures that heard on the ground, much like its sharp thunderclap and other like booming sounds when an aircraft exceeds the speed of sound. Data from the sonic boom mitigation study could eventually lead to aircraft designs that would reduce the peak of the sonic booms and minimize the startle effect they produce on the ground. Instruments at precise locations on the ground recorded the sonic booms as aircraft passes overhead at known altitudes and speeds. An F-16XL aircraft, I haven't got the picture of that, but perhaps I'll show you one of those in the next video. That aircraft was also used in the study. It was flown behind the SR71, probing the near field shockwave, while instrumentation recorded pressures and other atmospheric parameters. So that was NASA's involvement there. Research at Mach 3 speeds. Dryden had a Mach 3 history as well. Dryden has a decade of past experience at sustained speeds of Mach 3 and above. Two YF-12 aircraft, again that was the precursor, one of the precursors to the SR71. Let me see now. YF-12, that's the YF-12. Lots of similarities, but you notice at the front is difference. It's a shorter craft, and if you look right at the back, there's no classic boat tail shape that there is. You see the boat tail sort of design there on the SR71. The YF-12 didn't have that either. So there was a number of stark differences there. When we get into Dryden's research, 2 YF-12 aircraft were flown at the facility between December 1969 and 1979 in a joint NASA United States Air Force program to learn more about the capabilities and limitations of high-speed, high-altitude flight. The YF-12s were prototypes and planned interceptor aircraft based on the design that later evolved to the SR71 reconnaissance aircraft. Research information from the YF-12 program was used to validate analytical theories and wind tunnel test techniques to help improve the design and performance of future military and civil aircraft. The American supersonic transport project of the late 1960s to early 70s would have benefited greatly from this craft, the YF-12, and its research data. The aircraft were a YF-12A, tail #935 in brackets, and a YF-12C, tail #937 in brackets. There is a number of versions of the YF-12, a number of models. Tail number 937 was actually an SR71 that was called a YF-12C for security reasons. These aircraft logged a combined total of 242 flights during the program. A third aircraft, a YF-12A in brackets tail #936, was flown by Air Force crews early in the program. It was lost because of an in-flight fire in June 1971. The crew was okay, not hurt. The YF-12s were used for a wide range of experiments and research. Among the areas investigated were aerodynamic loads, aerodynamic drag, and skin friction. Talking about friction, the SR71 got very hot. We'll talk about that in the next video. Because of its high speed, friction with the air and fine particles, it's going to generate a lot of heat. So skin friction, heat transfer, thermal stresses, airframe, and propulsional systems, interactions, all this data was analysed for those things. Inlet control systems, high altitude turbulence was analysed, boundary layer flow, land gear dynamics, measurement of engine influence, and like for pollution studies, effluence, sorry, not influence, noise measurements, and evaluation of maintenance, monitoring and recording system. On many YF-12 flights, medical researchers obtained information on the physiological and biomedical aspects of crews flying at sustained high speeds. February 1972 until 1973, July 1973, a YF-12A was used for heat loads testing at Dryden's high temperature loads laboratory, now known as the Thermostructures Research Facility. The data helped improve theoretical prediction methods, and computer models of that era were dealing with structural loads, materials, heat distribution at up to 800 degrees Fahrenheit. The same surface temperatures reached during sustained speeds of Mach 3. So I want to talk a little bit about the engine research as well, the engines. A little bit here. I'll just try and find it. There we are. SR specification and performance. I would lightly go over this. Then we'll end the video and I'll do another one. So what I'm sharing is the most unexpected aspects, the things you might not think about. All the research leading up to the plane just didn't come out of nowhere without another set of planes and aircraft that were prelude to research to give them ideas of how they can improve and have the crystallization of the idea of the SR71. The SR71 obviously has been itself a very handy thing for gathering data to improve technology and further and for other planes and so on. And I'll be talking about SR72, like I said. So the SR71 was designed and built at the Lockheed Skunk Works, now known as Lockheed Martin. SR71 was powered by two Pratt & Whitney J58 axial flow turbojets with afterburners, each producing 32,500 pounds of thrust. So you can imagine like something as heavy as 32,500 pounds and so much thrust this gave. That's a huge amount of energy. Studies showed us that less than 20% of that total thrust was actually used to fly at Mach 3. Less than 20% of it was produced by the basic engine itself. The balance of the total thrust is produced by the unique design of the engine inlet and movable spike. The movable spike basically allowed a control of more intake for inlet or less inlet, depending on how the spike was moved. Most jet engines would be like, there'd be a preset intake and you get combustion and there'd be preset output. But this was way ahead of its time. Movable spike, it was just, this was incredible, mind-blowing really for the 1960s to design something like this. So, when I get the image back, you see the spikes on the wings there. Then they can be moved in or back out slightly. So the spike system at the front of the engine and the ejector nozzles at the exhaust, which burn air compressed in the engine bypass system. So you're controlling how much compressed air is coming in. You can have a lot coming in or less than the maximum as well by controlling those spikes. The speed of the aircraft is announced, the official speed is Mach 3.2. The point can be think of as a percent of the speed of sound. So faster than the speed of sound is 3 times 0.2% of the speed of sound, which equates to more than 2,000 miles per hour, otherwise known as 3,218.68 kilometers per hour. They have a unrefueled range of more than 2,000 miles and fly at altitudes of over 85,000 feet, which is about 25,908 meters. Bit of math there for you. As research platforms, the aircraft can cruise at Mach 3 more than 1 hour for thermal experiments. This can produce heat-soaked temperatures of over 600 degrees Fahrenheit. So the outer body, the outer plane, the surface, the skin of the craft, reached up to and slightly over 600 degrees Fahrenheit in places. That's a lot of heat. This is why they use primarily titanium for the craft, by the way, and other composite materials, but most of the craft on the outer surface was titanium. So you have titanium and titanium alloys as well to withstand this heat generated by Mach 3 flight. In aerodynamic control surfaces consist of all moving vertical tail surfaces above each engine. As you can see, above each engine at the back there's tails all above each wing. So incredible craft. The SR71 at Dryden have been assigned the following NASA tail numbers. NASA 844 on the A model, military serial number 64-17980, manufactured in July 1967, and NASA 831 on a B model, military serial number 64-17956, manufactured in September 1965. From 1991 through 1994, Dryden also had another A model, NASA 832, military serial number 64-17971, manufactured in October 1966. This aircraft was returned to the United States Air Force inventory and was the first aircraft reactivated for United States Air Force reconnaissance purposes in 1995. So this is a long haul for craft like this. Really, it's a lot of use, many applications. Again, it's not what people think about. The application you think of is going to war. For most of the layman people, and I'm no exception, I'm a layman, but I find this interesting to share. It's important to share for people to realise just how technology and our evolution with our technologies, how it affects us, how we affect it with ideas. It's a feedback loop. There's no such thing as technology and us evolving, if you will, with technology going in a straight linear line. It doesn't happen. We plateau and things get a little bit stagnant and people get frustrated with things perhaps and they want progress. And then we have a technological leap. And it's technologies like this has helped us gather analysis of things. Through these experiments, we're analysing things for the pollution as well. Many other applications here that a lot of people just do not think about. So I'm going to leave it at that. I'll see you in next video, hopefully. And, I won't see you per se, but hopefully you'll join the Exploratory Minds project, have a look at the website perhaps. Hope you've enjoyed this one. I'll do part 2 soon. Check out these YouTubers, by the way. They're awesome. Brilliant cook, first one. Steve McRae, awesome, very charitable individual, I think. Rez Rhetoric, I don't know if I spelt that right. If I haven't, my apologies. And Cheshire Vic, awesome artist. I've got some of her videos on a playlist. Brilliant. One last thing to say is the following. So thank you very much for watching. Take care. And I look forward to doing in the next video. Cheers. Bye.